We will be using two variables, D1 and D9, to illustrate the use of Minitab for describing data. D1 has 50 values randomly selected from a normal distribution with a mean value of 7 and a standard deviation of 0.5, and D9 consists of 50 integer values. We can describe data either through the stat option or through the graph option. We can do individual plots, for example the histogram, a dot plot, bar charts, pie charts. But we will start with a stem and leaf plot. We will use the variable D1. The stem and leaf plot will be printed in the session window, where we can see that for D1 we have 50 values. The second column gives the unit value of the data, so we have values with unit values of 5, 6, 7 and 8. And the third column, the decimal values. So for example, we have got one record which has a numerical value of 5.9, and we have 3 records which have values of 6.2. It has automatically decided to divide values with the same unit value into 5 separate categories. So we would here record items with a value of either 6.0 or 6.1, values of 6.2, 6.3, etc. The shape of this stem and leaf plot then gives an indication of the number of data values within each subcategory within the data. And also in column 1, it lists the cumulative number starting from each end of the distribution, moving towards the median value. So we find that up to 6.9 we have a total of 25 values, and then from 7.0 up we have another 25 values. So we have the median value of 7 with 25 values on either side. In addition to graphs, we get more detailed numerical information using stat and basic statistics. So we can select display descriptive statistics. We will choose the variable D9. Under statistics, we have a range of options that we can select for the statistics. We will keep mean, standard error of the mean, standard deviation, the various quartile measurements, and for example we will also include in this one skewness and kurtosis. Click OK. If the data was subdivided into different groups that were identified by a separate variable, we could use that variable to plot the data separately within each group. And under graphs, we could choose a histogram of data and with a normal curve. Click OK, and then we will run the analysis. The histogram here shows the numbers, the frequency of entries within each particular category, and it has superimposed a best fit normal distribution for this data, but it appears that this data is not symmetrical and does have a certain positive skewness. If we wish, we could edit this display by double clicking on a particular element. So for example, if we double click on the x-axis, we have various editing options. In terms of display, we can change the font, but we could also, if we wished, change the binning of the data, although we see that Minitab has automatically selected individual unit values, which is convenient for this particular display. But for a numerical output, we need to go to the session window, and here we can see the descriptive statistics for D9, which shows mean, standard error of the mean, standard deviation, etc. It gives the analysis in terms of the lower and upper quartiles and the median value, and it also shows values for skewness and kurtosis. And we see that there is a certain amount of positive skewness within this data. We can also use the graphical summary available within basic statistics. Basic Statistics, Graphical Summary. And again, we will choose D9, where we can see we have got a mixture of the graphical and numerical results. Again, we have the histogram with its normality plot. We have a box and whisker plot for the data. We also have now confidence intervals for the mean and median value of the population from which this data was drawn. It also gives various numerical analyses of the data. It performs an Anderson-Darling normality test, where we can see the p-value is 0.036, suggests that we should reject the null hypothesis in this test that the data was derived from a normal distribution. And we have already observed the fact that it does appear to have a positive skewness, which would be consistent for a set of integer values such as this, which may well follow a Poisson distribution. It gives the mean and standard deviation values of the data and the variance, values of skewness and kurtosis that we've seen before, and then calculations of quartile values, and then numerical values for the various confidence intervals.